Hello, in this video, we'll show you how we can use a multi-agentic framework to query structured data sets. The key building blocks for this tutorial are going to be the Crew AI open source framework, the LangChain framework for using the SQL database toolkit, the Llama 3.3 LLM model, and Docker for allowing code execution. The first agent is an understanding agent. This agent is essentially responsible for interpreting the user query. The second agent is the schema analysis agent, and this agent is responsible for analyzing the database schema. The third agent is the SQL query agent, which constructs the SQL query. And the fourth agent is a coding agent, which is going to be a separate agent that we will use for transforming the existing data set which we have. Each of these agents have a task assigned to them. Each of the tasks can use tools as input, which allow the agents to perform certain instructions that they are provided. So the schema analysis agent and the SQL query agent are using the LangChain SQL database toolkit. The Python coding agent is not using any code interpreter tools. Since we're using the Llama 3.3 70 billion parameter model, this model already has its own built-in code interpreter tool, which makes it easier for generating Python code. So the end users will upload their private datasets and also provide a user query. The first agent, the understanding agent, will analyze the user query and then provide its context to the schema analysis agent. This agent will then analyze the database by using the context from the understanding agent and then pass on the schema database information to the SQL query agent. The SQL query agent will then generate a SQL query, which is executed on the database. The context is preserved through the tasks for each of the agents. That is how we make sure that there is no loss of information when the agents are communicating with each other. The same applies for the coding agent. The understanding agent will analyze the user query and then provide context to the coding agent, which will then generate the Python code. Once the SQL query is executed on the database, the results are then provided to the user in a data frame, and the chat history is also stored in the system memory. We can include this to be short-term memory or long-term memory, depending on how we want to implement the use case. Now I'll show you how we can use these AI agents for querying a structured data set and also transforming the data. First, we'll upload the CSV files to the application. The CSV files are converted into an SQLite database, and each CSV file is converted into its own respective table. We can see the columns present in each of the tables after the database is created. To configure the LLM model, we'll be using the Together AI platform, and we'll be using the Llama 3.3 70 billion parameter model. This model is better suited for writing code as it has its own built-in code interpreter tool. We can see the agents, the tasks, and the tools which we covered in the previous video. Let's ask the question saying, list the products reordered the most by users. We want to see which products are being reordered frequently from this database. Once the agent writes the SQL query, the query is executed on the SQLite database, and we can see the query results. We can see the entire list of all the products and also how many times they've been reordered. We can see that bananas are reordered the most. We can also see the token usage as well as each of the task outputs from the AI agents. The first task is to understand the user's question and break down the components to figure out what the user wants to retrieve. The second task is to find the relevant columns in the database, and the third task is to generate the SQL query. Let's add some more context to the next question. Which product is reordered the most in each department? Here, we want to find which product in each department users are ordering more frequently. We can see the generated SQL query as well as the results from the database. Here we can see that in the bakery department, it's whole wheat bread. If we take a look at the produce department, we can see that bananas are reordered the most. We can see the task outputs as well, and we can try to sort of follow how each of the agents was trying to process the information and provide the final SQL query. Let's try asking a question that requires some more thinking from the AI agents. Let's try to ask which liquid products are sold more. Find the departments and aisles selling liquid products. So here, the agent needs to understand what is a liquid product. Here, a liquid product can mean anything from detergents to cooking oil to soda, juice, anything, right? Unfortunately, here we see that the generated SQL query is listing all the products that contain the word liquid in it. We see that the agent was able to categorize liquid products, and we can see that the agent is able to categorize them as beverages, cleaning supplies, and other products that you find in any retail supermarket store. However, the final query still says they are liquid products. So how can we provide more context to the SQL agents? We can have a Python coding agent that can be tasked to essentially transform the existing data which we have. We will not be changing any of the existing columns. We will in fact be adding new columns that provide more context and information about the products in the dataset. Here in the task, we can see that we are telling the agent to create some new columns and also explain what the data is. We also instructed what kind of a Python function to transform the CSV files and create these new columns. So let's kick off the agent and get the Python code we need. So if I ask the agent to write me the Python script I need to create the new data set with the new product feature columns, the agent will write me the Python code, and we can see that using the CSV files, it was able to create a merged data set with the ID columns and also create the new product feature columns and assign values based on certain keywords that are present in each of the product names. We can see that the new created data set is saved to a separate file. So once we modify and run the Python script to create this new CSV file, we can then import it into our application. We will update the database with this new CSV file, and the new file is created as its own table. We can see the new columns that were created by asking the coding agent to transform the existing data. So let's try asking the same question, but let's tell the agent to refer to the merged data set we have created. Here we have a column that tells whether a product contains liquid, and we are essentially telling the agent to refer to that column. And here we can see the agent putting a condition where that column contains the value 1. And here we can see a list of different types of liquids like water, juice. Let's try asking another question. Which fruits and vegetables are users buying more? Here we're not telling the agent to look at any specific column or database. And here we can see that the agent is referring to a specific department in the dataset. We can see a list of different fruits and vegetables from the database, and we can also try to follow how the agent was processing this user question. How do we know that this query is correct? If we check the database, we can see that department ID 4 is the produce department, and we know that the produce department does sell or stack fruits and vegetables. So this is how we can build a multi-agentic AI framework for querying structured data sets and also for transforming these structured data sets. Thank you for watching, and stay tuned for more videos.